Okay, here we go. All right, law of cosines. I'm just going to kind of just jump right into it. The law of cosines is right there. And we'll give you these formulas. Don't worry about it. We'll give them to you. It looks a little daunting at first, like, oh my God, it's all these letters and all these symbols and squares and whatnot. It's not that hard. But what you've learned so far, and actually that's a typo. That should be SAA, guys. Sorry about that. It should be SAA. So what you've learned so far is that if I gave you these scenarios, side, angle, 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 side, angle, or side, side, angle, you can do law of sines for any of these three. Because you have known angle side pair, right?
Like I have these two angles here. Well, yeah, I already know the side angle here. I know this angle side here. Well, here I know these two angles, but I should know this angle, right? If I know two angles, let's say it's like 30, 60, that's 90, or 40, 70, that's 70. I know that. For here, I've got two sides of an angle, at least I've known angle side pair. And of course, this would be ambiguous. Lots of the side angle. That could be ambiguous.
However, what if I gave you this? What if I gave you this? All three sides with no angles. That's clear side, 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 right? Or two sides, an angle in between. Here's the problem.
I know okay, so I don't know any angles. I can't do law signs. If I try to do law signs, I have two unknowns, right? Like for example, if I have this like A, B, and C, right? So and say this is little a, little b, little c. So I do sine angle A is a little a, and sine angle B of a little b. Fine, I know little a and little b. And say those are like 3 and 4. If I don't know these two angles, I can't do law signs, right? You can't solve an equation two variables. It's impossible, right? Same thing here. If I have so this is like A, B, C. So sine B of little b, little a, little c, or little b equals sine A, little a. I can't do that, right? Because I know this angle, I know this side. I don't know. Hold on a sec. Yeah, I don't know angle A or side A or side B. Yeah. So I don't know angle A. So these two I don't know. I know these two. I don't know these two, right? So I was getting confused. I don't know these two. So it's still like two unknowns. So you don't have a known angle side pair, so you can't do it. So you have another formula called the law of distance, right? That's the law of distance. Don't get confused. It's three variations. Honestly, don't even worry about it. Just make sure that this is opposite of this. That's all that matters. Just make sure this angle is opposite the variable on the left side of the equation. So the variable on the left side of the equation has an opposite angle. That's it. These are interchangeable. Because who cares if you're adding first or second? Doesn't matter. Where you multiply first, second doesn't matter. These are interchangeable. So it actually, I'm going to kind of get away from the formula so much because I don't want you guys getting so caught up in plugging into a formula. I mean, yes, we do three variations of it because you don't know what angle you're given, A, B, or C. But bottom line is, if you can't do law of sines, this is another way you could do it, called law of cosines. Now, the way that's derived, I'm not going to show you. I did show you how law of sines was derived. If you took a triangle, dropped the altitude, and did SOHCAHTOA stuff, I showed you how that was done. If you forgot, don't worry. But law of cosines is kind of crazy, so we don't worry about it. Okay, what would happen if the include angle is 90 degrees? So let's say I had this situation here, guys. Let's say I had 90 degrees. Let's say that was 4. Let's say that was 5. So here's the thing. If I want to find that area, if I want to find this side here, right? Oh, yeah, it's gone. Cal. I'm a Stanford guy. Sorry. Stanford sucks at football. Anyway, no, but like, if you have this, how would I find this missing side? Do I need to use law of cosines or use another famous theorem? Just use Pythagorean theorem, right? Yeah, like if I call this like C, for example, why would I even use this? I mean, sure, I could use this form if I wanted to. 2 times 4 times 5 times cosine 90 degrees. But what's cosine 90 degrees? You guys remember? Unit circle?
It's 0, so it goes away anyway. It doesn't matter. So what happens if the angle is 90 degrees? Just use Pythagorean theorem. That's because the law of cosines becomes the Pythagorean theorem. And actually, let me type that up to be a little more explicit here. The law of cosines then becomes the Pythagorean theorem, since cosine of 90 degrees is 0. Yeah, that's all. So that makes sense. We're good? All right. And then it's important to note there will be cases where you may want to use law of sines partway through the problem, and in bigger situation may occur as a result. So stick with the law of cosines for most of it, because the law of the ambiguous case can kind of creep back in when you're doing this technique. Because, well, let me just do a problem first. It'll make more sense what's being discussed there. So let's do a problem, and then we'll do then another one, and then we'll talk about another form for area. And that should conclude our notes. So 4 examples. Here we go. Okay, so what do we got here? And Liam, we got a slip, right? You good? Okay, great. All right, so yeah, let's draw this. So see here, I'll call this angle A. That's 41 degrees. I'll call this B, and I'll call this C. So that's 10, I know this, and that's 20, I know this. So side angle side, right? Okay, I don't know angle B, I don't know angle C, and I don't know little a. The 3 things I don't know. I can't do law of sines, unfortunately, I just can't.
How can I do law of sines? Because do I know the side opposite 41 degrees? No. Do I know the angle opposite 10? No. Do I know the angle opposite 20? No. No known inside pairs. You're trying to do law of sines right now, you're going to turn out to make it. So you have to do the law of cosines.
Now, here's the deal. What's opposite 41 degrees, guys? A, right? So just say this, a squared equals 10 squared plus 20 squared minus 2 times 10 times 20 times cosine 41 degrees. There's no need to get too caught up in memorizing, oh, which of the law of cosines formula am I going to use? Which of the 3 variations? It doesn't matter, because the bottom line is that
whatever this angle is, this side has to be the one opposite 40 degrees. Right? That has to be opposite 40 degrees. And then you just work it out.
Now, I'm going to caution you guys. When you work, actually, it would be a second example. For now, I think you guys will calculate this just fine. There's going to be a very common error in example 2. We'll come back to it in a few minutes. And example 2 is a very common error people will make. I'm going to talk about that common error in just a sec. For now, this should be pretty straightforward. That's going to be 100 plus 400 minus 400 times cosine 41 degrees. If you plug all that into the calculator, actually, I'm going to pull up the calculator right now. Okay. 10 squared plus 20 squared minus 400 times cosine 41. Mode, degree. Yeah, very, very important. Be in the right mode. Because if you're not, just so you see what happens. I'm actually kind of curious if I do this again. That seems really large, right, guys? If I were to take the square root of that, raise it to 1/2 power, I mean, I guess that can coexist, but that just seems really large. That's why I want a square root. And you can put square or raise to 1/2, same thing. So 14.08 seems reasonable to me. In terms of rounding, actually, let's go 3 decimal places. So we'll do 14.075. Just be a little more precise. So 14.075. And actually, A would be the square root of all that junk. So 14.075. Okay, cool. Where are my notes? There we go. Okay, so 14.075. I think we're good there. That's probably a bit of a pain in the ass because here's the thing. How am I gonna get angle B or C now? What do I have to do? You lost signs. You can do log cosines again too if you want, but personally I do log signs. It's a little less intensive. But yeah, totally. I think so. Totally law signs. So sine B. It's up to you. You can solve for B or C first. It doesn't matter. It's your call. But now I'm going to use 41 degrees and 14.075 because now I have a known angle side pair. Right? I have a known angle side pair. And I'll do it over here. Question? Question?
Which one part? Oh, sine 41 degrees, sine B. Yeah.
Yeah, my handwriting stinks, so don't totally ask. Okay. Jack and Barry company. I don't feel like pulling the one on my device here. It's just not enough space. So let's see here. 20 sine 41 divided by 14.075. You get 0.933, 0.932. No, that's what sine B equals. My bad. So B is the inverse sine of that. And if you think about it, this is kind of like a side-side angle case, right? You know, it's because you have a side-side, you know, it's kind of like that. If I do the inverse sine of it, let's see here, I get 68.786 degrees. 68.786 degrees. And then I do 180 minus that to get the other 180 minus 68.76 minus 41, and you get 70.24 degrees. And that's that. And I think that should be actually, hold on a sec. Hold on a sec, guys. This is not correct. Let me check my notes really fast here. This is gonna be a weird one. Yeah. Okay. So I was correct in saying this is kind of like the ambiguous case, right? Because I'm doing inverse sine. Here's the deal. So I didn't quite give you guys accurate information. I'll explain why in a sec. See if I can do my writings. Here we go. Okay. So yes, I did get 68.76 degrees. However, I did mention you do need to consider its supplement. Whenever you do the inverse sine, you have to always consider that. 180 minus 68.786, which would be 111.214. Now let me ask this question.
Can 111.214 Moses of 41?
Yes.
Yeah. Okay. However, we have 3 sides now, right? So it's like, what gives, right? We have 3 sides. How is this going to be ambiguous? Here's what you have to do. You have to make a decision. You have to choose between the two.
Is it going to be 68.76 degrees or is it going to be 111.214? How do you make that decision? How do you choose which one it's going to be? Here's what you have to do. It's going to be this one. Here's why. I know, it's weird. I know, it's really crappy. Here's what you have to look at. What are your sides now? 10, 14.075, and 20, right? Those are your three sides. The problem is this. If I try doing Pythagorean theorem, I know it's not a right triangle, but if I try doing it, here's what's going to happen. That side's going to be 400. This side's going to be, I think, 296. If I work this side out, roughly 296. Whenever this happens, the triangle becomes obtuse. It's called the Pythagorean inequality theorem. You guys did do in geometry a long time ago, or maybe did not. I don't know. Should have. But when this happens, when you do a squared plus b squared and c squared, if it equals each other, you know it's a right triangle. That we know. If the a squared plus b squared is greater than the c squared, it's acute, because that means that the triangle is going to cave in a little bit. It's not going to be a right triangle anymore. But if the angle where the right angle was expands, it makes the longest side almost too big. Not too big where it's not a triangle anymore, but where it becomes obtuse. And that's what's happening here. So you have to do, what you have to do is you have to do something called you have to do this. You have to compare a squared plus b squared versus c squared. You have to compare those two. If c squared is bigger than a squared plus b squared, then yeah, it just doesn't work. And when I say c squared, I mean by that is the longest side. The longest side. Technically, we were looking at b as the longest side, but that's neither here nor there. The bottom is you have to make sure this is obtuse or acute, and it is obtuse, unfortunately. And then I could get the other side. Plus 41, 180 minus that. Yeah, you get 27, 0.786 degrees. Landline, go ahead. It does, and this is the long side. But the things that I don't know, actually, yeah, that's a great observation, Landline. I like that because if I did go 68.786, angle C was me 70 degrees, right? Actually, I like what you did too. Let's okay. So I gave you guys a more detailed way of looking at it, totally. But actually, let me clear this for a moment. I had this originally, right? I had this at 68 degrees. That's 70 degrees, and that's 14. But that wouldn't have made sense because then this would have been opposite, not the longest side, the small side. So then that's another way of looking at it too. I like that. Totally, yeah. So the bottom line is you gotta take this with a grain of salt when you do the inverse sign, when you do the law of signs afterwards. So yeah, these are a little crazy. Let's move on to the next one.
So what if you did sign to have gotten something?
Well, how do you do law of signs? If you did law of cosines, actually, it would have given me the correct answer, right? If I didn't do law of signs at all, yeah, it would give me the correct answer, right? Because it doesn't have the ambiguity that comes with it. Yeah, let's not look at this one here. I know three sides here. Okay, great. I'll call this 7, 12, and 15. Angle C, angle B, and angle A. Okay. Well, let's work it out. I'm going to do the law of now. What angle do you want to find? Does it matter which angle I start with? No, right? Let's find angle A. So I'm going to use this formula here. It doesn't matter what side you want to find first. It's totally up to you. So I'll do 7 squared equals 12 squared plus 15 squared minus 2 times 12 times 15 times cosine A. Okay. So 49 equals 144 plus 225 minus whatever 24 times 15 is, 360 times cosine A. Now, here's where I caution you. What some students will do, don't write this down. what some students will do is they'll do this. 49 equals, they'll add 144 to 225, which is what, 369, I think. Yeah. Don't write this down. What I'm doing is bad right now. And then they'll do 369 minus 360. You see what I just did wrong, guys? What did I do wrong?
I just made one operations, didn't I? Because what's 360 being multiplied? We're gonna have to multiply for our subtract. So each one is evaded. You're gonna get a wrong answer. This happens almost everyone I teach this or someone who does this. I'd like that question to be perfect, and no one does this mistake in this class. That'd be awesome if that happens. No one finds a present or something. That's good. There's one I'll do these nice things for you. But anyway. No, I just don't do it. Just don't do it. What you need to do instead is subtract the 369 first.
Subtract, because the cosine is like a variable now, right? It's an unknown. Now this you do want to do. I'll continue in red, in the same color. This you do want to do. 49 equals 369 minus 360 cosine A. Then move the 369 over, which is negative 320. Ah, I can't do threes here. Okay, that's much better now. I feel much better about this. Cosine A, 320 divided by 360, 0.889. And we do the inverse cosine, we get 27.266 degrees. So that's angle A. Now, if you want, you could do the law of sines, or you could do law of cosines again. It's up to you. If you do law of cosines again, we could do law of cosines again. It's your call. Does that make sense what I just did? Right? Okay. In the interest of space, let me do it up here. So let's solve for b now. I'll say b squared equals a squared plus c squared minus 2ac. Again, you can do law of sines or law of cosines. We'll just do law of cosines again. So you're gonna have 12 squared equals 7 squared plus 15 squared minus 2 times 7 times 15 times cosine b. And I'm just skipping some steps, guys. You should get 51.75 degrees. I'm skipping some steps here. You just work it out. Isolate angle B with do the inverse cosine. And then lastly, angle C would be 180 minus the sum of those two. And I should get 100.98 degrees. Or 981 degrees. And that was 0.753, by the way. Degrees. I think it makes sense. Yeah, that makes sense. So yeah, there you go. Again, just a lot of plug and chug, a lot of formula stuff. Okay, questions? No?
Wait, so at the,
Liam, go ahead.
you have to do part back to see which number you take.
Yes, that was when I was doing law of sines, when there's that ambiguity. And then that when I compared the three sides I knew, I did a squared plus b squared equals c squared. Of course, they're not going to equal each other. It's not a right triangle. But if c squared is bigger than a squared plus b squared, you have an obtuse triangle. So you have to go to the obtuse angle. So I like what Lamlad said. Hers idea was better, was that when I did it and I saw that, wait one sec, my biggest angle is opposite the small side.
Yeah.
That didn't make sense because if I stuck with 60 in the previous example, if I stuck with 68 degrees, then angle C was 70 degrees, but then it was opposite 10. That didn't make sense, right? Yeah. So I guess that because I had to go with the obtuse angle, so it physically made sense that the largest angle is opposite the longest side. Okay. So, yeah. So I think what Landless said was actually that, but you do have to do some sort of check. You have to make sure you can't just go with it and say, oh, make sense, but physical, it doesn't make physical sense. And by the way, we are going to pump the brakes. I see you guys tomorrow, right? Yeah, tomorrow afternoon. We're not going to do 6-4 tomorrow. We're actually going to go back and look at everything we've done so far. 6-4 is kind of like a word problem situation. We'll do it on Friday, and then we're going to review on Tuesday of next week. But we are going to pump the brakes a little bit tomorrow and let's just do a review of what we've done so far, because a lot of stuff I've shared with you guys. Okay, one more formula. I'll be honest, like this is a form that I will forget. I know it because I teach this stuff, but if I hadn't taught pre-cal for 2 or 3 years, I would not remember this. Or if I'd like stopped teaching for 2 or 3 years, or after when I was on paternity leave, I forgot this formula because it's not something you see that often. It's a very, very funky formula, but it's pretty cool because if you're given all 3 sides, it's not a right triangle, you can find area. You don't have to do area because 1/2 times base times height. The derivation for it, it's kind of complicated. I'm not going to do that. Actually, I don't even know. I have to look it up, to be honest with you. But similar to the other one we did, 1/2 a b sine c. We had that formula in the previous class. Kind of similar here, but this is when you're given all 3 sides. So you're given all 3 sides, right? 5, 8, 9. Now S, let me tell you what S stands for. S stands for the semi-perimeter. So it's half the perimeter. There we go. Take the perimeter, divide by 2. Boom, done. So what's my semi-perimeter? That's going to be 11, I think. Yep. And just plug away. 11 times 11 minus 5 times 11 minus 9 times 11 minus 8. That's all. That's all you're doing. Super easy. If I work all that out, what do I get? 11 times 6 times 2 times 3. I should get 66 times 6. Or, I've already calculated that. 390. Thanks. And then if I do that, that's also going to be kind of nasty. 19.9. So that's area, 19.9. And you should give units, by the way, if units are provided. It's square feet. So that's the area of the triangle. Yeah, it's just plug and chug. It's not that hard. It's a very vanilla type problem, but it is what it is. So here's another one that we could do one more time. Yeah, there you go. Oh, sorry, this is not area. This is just law of cosines. How many degrees did the ship turn from its original easterly heading? Hold on, let me read this again. Traveled 40 miles east, then took a northerly turn. When the trip traveled 30 miles, obviously heading was 56 miles from its departure. How many degrees did the ship turn from its original? Oh, okay, so they want this then. They want this, guys. So that's not that hard. You guys can do that. 56 squared equals 40 squared plus 30 squared. Minus 2 times 40 times 30 times cosine of angle B. Work it all out. When you get very good with this, you can just do this, guys. When you get very, very good at this, you just say, okay, well, you don't have to show all these steps. You just do 56 squared, right? And what are you going to subtract that by? 40 squared minus 30 squared, right? But don't subtract the other one just yet. You got to divide it. Then divide it by parentheses. And it's going to be negative, by the way. It is going to be negative. Negative 2 times 40 times 30. And then take inverse cosine of that. Wait. See, this is why you gotta check the mode. So let me do that. And it's normal cosine anyway. You guys are correct. But regardless, it goes off. And that should be obtuse, I think. Yep. Because second quadrant. 105.367 degrees. Which makes sense. It's opposite the biggest side. That totally makes sense. Plus if I check 30 squared plus 40 squared is 2500. That's less than 56 squared. So yeah, it totally should be obtuse. That makes sense. Yep. All right, there you go. That's what we do. All right, so we're gonna start the quiz. Homework, just gonna be this part right here. We'll say homework 30. I'll put in, it's already in Schoology right now. The answer key's up as well. So you guys know what you have to do for homework. And let's do quiz. Just one question.
Yeah, you will need a graphic calculator. Now go hold. That's something.
My calculator is dead too. Okay. Anyway, wasn't going the right direction right here? This was.
Yeah, no, that's fine. Then you divide. Oh, wait. That's 2500.
Oh, okay, that's good.
Yeah, we'll be right back. Who else needed one?